Assalamu alaikum all of you. Welcome to one more session for the data representation. Okay, now in this session we will be dealing about the sound sampling and all, and what is sampling, what is sampling rate, small definitions, and we will be dealing with the RLE method that by utilizing the RLE method. Okay, after this topic, our topic for the data representation will be winded up. Yeah, but we will be left with few of the things. Like, what are we left with? We are left with the lossy and the lossless compression techniques, and we are left with one more thing, that is how we're going to uh, place up the file, the compression of the files. We are left with that thing. Why are we not doing that right at the moment? Okay, we are not doing that because I will be dealing them with when we are dealing with the data storage and the data storage devices. So over there I will be introducing you this part of the topic, that is the remaining topic from the data representation. I will be introducing you with that topic over there. Okay, now coming towards the sampling. What is the sampling? So processing of any sort of the data. Now it could be the sound data, it could be the images, it could be the video data, or any sort of the thing. So sampling is something that whenever you're going to process the data. Now what is a sampling rate? Now sampling rate is something that the processing of a data within that particular time, उस particular time के अंदर, that whenever we are going to the given time or the given interval of the time, what sort of the data or how much data are we going to process in that particular interval, that is known as the sampling rate. Now before starting with the RLE, coming towards the pixels, we are already done with the bit. So pixel, as I just told you in the previous videos, that bit is the smallest unit of the memory that can be processed by the system. Similarly, what is a pixel? Pixel is something smallest unit of an image. Now for an example, we do have an image over here right at the moment. The smallest element, there are the dots over here. So the smallest element of this image is known as a pixel. Coming towards the resolution. Resolution is something how many pixels are present in the width, and how, or you may say it as the length, and how many pixels are present in the length. So multiply each of them, length into width. For example, there are 20 pixels in the length and there are 14 pixels in the width. So total number of the pixels will be we will be getting after that. Now coming towards the dot pitch. Now what is a dot pitch over here? So dot pitch is something distance between the pixels. So there are two different pixels, so distance between them. So distance between them is known as a dot pitch. Now if we are going to zoom it in, हम जितना the image like how much we are going to zoom it in, I'm sorry for the Urdu, so how much we are going to zoom it in, we are actually increasing the distance between the pixels. So you might have seen that if you zoom a lot, we are zooming it in a lot to the image, so you might see that it gets pixelated. Now what do you mean by the pixelated? Pixelated is something that it started to burst, the pixels started to burst at the moment. At that moment you have increased the distance between the pixels a lot, so this is the reason that you are getting it a pixelated image. So the distance between the pixels is known as the dot pitch. Okay, now as much as near they will be, as much as the less the dot pitch is going to be, the image will be that much sharper. Yeah, but it will be of, if it's of a high quality, so it is going to take a lot of this space as well. Make sure for one thing. Coming towards the RLE. Now RLE is a type of compression technique. It is usually utilized over the bitmap images. Now what are the bitmap images? So bitmap images is something that is having a colored images, or they are having the pixels in them. Now RLE. So RLE is a compression technique utilized for the bitmap images. Now how is RLE working? Now consider that this is an image right at the moment. These are the pixels, each of them 4 pixels in each row and 3 pixels in each column. Now out of these 4 pixels for the first row, 3 of them are shaded right at the moment and 1 is not shaded. So for the shaded part I just took it as the B, and for the non-shaded part I took it as the W. Now what I'm saying right at the moment, I'm saying that I will be compressing in a row wise format. I will be writing each of them, or each of the images, or each of the pixels together, that are in a continuous format. So if I see over here, I just wrote 3B 1W. Why I wrote 3B 1W? Because there were 3 shaded pixels and a 1 non-shaded pixel. 3 shaded pixels were in a continuous format and then a 1 non-shaded format. Now we do have one for the second row. So I utilize a comma just to represent that I'm going on the second row. Now I do have one non-shaded part, 2 consecutive shaded parts, and again a 1 non-shaded. So do remember that there are 2 unshaded and 2 shaded parts, but I cannot merge them with 2 non-shaded parts. So I just wrote 1W, 2B, and again a 1W. And finally, coming towards the third one, again we do have 2 non-shaded areas consecutive, two shaded areas consecutive and 1 shaded area separately. So I will be writing 1B, 2W, and in between it's 1B, 2B, and in between there is a 1W right at the moment, that is the notch. So do remember, for the RLE we are going to write down the consecutive values or the consecutive patterns together. If they are not consecutive, we are not going to merge them together. So this is how the RLE works. Thank you so much, guys. That was all for the data representation. Hope to see you guys for the data transmission in next topic of ours. Thank you so much. Allah Hafiz.